Hey, it's Moser with hints and tips on the 4B problems. This is number 5 from the 4B worksheet. So we've got Bob, who's a big guy, and after winning, the happy teammates throw him up in the air but don't catch him. He hits the ground. Ouch. And his average upward acceleration over the course of the collision is 75.0 meters per second squared. This is bigger than free fall. We knew that. So to start off with, I'm going to go ahead and draw a free body diagram, and what I've drawn here is a free body diagram of Bob if he was just laying on the ground. But he's not. So there's additional normal force pushing up on him because he's experiencing an upward acceleration. So intuitively, we do know that the upward force on him has to be greater than the downward force, since we know that he is having an upward acceleration. Okay, so just to get a couple things out of the way, I would set aside the fact that there's no forces on the x-axis. In other words, sum of forces on the x is 0, and we're not told there are any forces there whatsoever. Then, I'm going to start with this familiar bit that I usually start with. Sum of forces on the y is equal to all the forces up minus all the forces down. Well, in that case, this is normal force minus the force of gravity. But it's also equal to ma. That is the sum of forces on the y-axis. So let's set those two equal to one another. There we go. Mass times acceleration is equal to normal force minus the force of gravity down on Bob. And I know that, in fact, the force of gravity is really just mass times gravity. What am I solving for? Oh yeah, normal force. Honestly, you can probably stop the video right now, but if you need me to go to the last step, wouldn't that look something like this? Excellent. Get going.